All right, Atomic Structure 9, physical versus chemical properties of elements. What is the difference between the two? So just from the start, right from the start, physical, the elements do not change. There's no change in their composition, their identity. But in chemical, there's a change. It becomes a new substance. So that's the easy definition of that. Well, let's get a clean page. Let's get the pen first. Well, let's use yellow. So again, with physical does not change. Does not change. I won't go over that. Does not change. And chemical changes. The elements will change, become a new substance. So just think of that. All right, and here's a periodic table. So, just looking at the periodic table, it goes from metals to gases. We have the metals over here. We have soft metals. Let's use our pen. Let's use purple. So we have our soft metals like sodium, potassium over here. And over here we have our gases like neon and fluorine and oxygen and nitrogen. You know these. And so you could look at certain elements and you can look at them by color. That's one characteristic, that is. So, for example, sodium, we talked about sodium. That's sodium, right? Sodium is silver. It has a silver color to it. In fact, most elements are either silver or gray, or they have no color. Like sodium is silver, and guess what silver is? Silver is silver, right? So you can go by color and you can check. And mercury, believe it or not, some people think it's red, but mercury is also silver in color. And we know some, so let's say we look at carbon over here. Carbon is black. So there's a color on that. And copper, we'll look at copper. I'm sure we know that copper has a copper color, and we say like a red-brown color, red-brown tannish color, right? So that's copper. Iron is gray. Iron has a gray color to it, unless it rusts, which is a chemical change, by the way. Sulfur. Sulfur is yellow. Sulfur is yellow, right? So color can tell you some characteristics of the elements. And I'm sure we know what the color of gold is right over here. Gold was gold, right? Color, and there's silver on top. So color is one characteristic of physical properties. Let's look at some others. So on the left, we see our physical properties, and we'll go over them. We just went over color, for example. Length is obvious, how long something is. Volume, we'll talk about volume and density in a minute. Opacity here, let's circle that. Let's use that color, opacity. So with opacity, we're talking about how much light will go through. How much, fix that M, how much light, fix that G also, how much light will pass through the material. And so when you're thinking of that, there are three terms, three definitions you should be familiar with. Let's put them over here. Let's put this arrow all the way over here. And so you probably heard of transparency. Let's write that down. Transparency. Get it in there. We're fitting it in. So in transparency, all light goes through. All light. We'll just put all light goes through. And then you may have heard of, and let's use another color so it doesn't get too blurry. And then we have translucency. Translucency. In translucency, some light. Could be a lot, could be a little, but some light. Not all the light will pass through in translucency. And then, of course, one more color, opaque. So in opaque, no light goes through. So that's a fit. Those are physical properties. And then what chemical properties we'll talk about next. We'll start with physical, and then we'll go into the chemical properties. But just, again, a very simple thing. If the element is not changing, if the compound doesn't change, for example, if there's no change, it's a physical property. If there is change, if you're observing change, then it's a chemical property. All right, and then we have malleability. It's also a physical property. So, for example, and this really pertains a lot to metals. Let's say we're taking a bar of gold. There's our gold at Fort Knox or wherever. It looks like a bar of gold, something like that, right? And here's our gold. So malleability is the ability of an element to be hammered into sheets using Thor's hammer. Or some hammer, right? And so when you hammer gold, and by the way, the most malleable element is gold, the most malleable is gold. You hammer gold and then you can make flat sheets. You can make flat sheets better than any other element. Nice sheet of gold. So that's what malleability is. And again, that's a physical property. And solubility, we understand solubility. Let's use blue. Why not? So, we have a glass here. Transparent. Unless it's frosted glass. And then it'll be translucent. But so here's this glass and it's filled with water. And we put salt in, right? We put Na for salt. There's our salt crystal. So solubility is the ability of a substance. And usually when we say solubility, we're talking about solid mixing with liquid. Miscibility is liquid with liquid. So solid mixing with liquid. And so in this case, we'll have, sodium. Actually, I shouldn't just put Na because it's sodium chloride. It's a compound, sodium chloride, which is NaCl, right? Sodium and chlorine. So we should put our Cl there. There's our Cl. So when this mixes, and you know this, when we put these two together, we get salt water. So this is a mixture, but inside the water, it's still salt. Salt hasn't changed. It's still salt, and water is still water, even though it has a salty taste to it. That's why it's a physical property. Now, like I said, miscibility is when liquid mixes with a liquid, right? So, for example, if we had some water here. Here's our water. And we filled up that with water. And then if we put in, let's say, we'll use that color, oil. Oil and water don't mix. So there wouldn't be a miscibility here. So oil and water, let's put it down here. Oil and water are immiscible. Don't have someone call you immiscible. Sounds like some word like that. Then again, if we made another glass here and we mixed water with alcohol, it would mix. So water and alcohol will mix together, and there is miscibility involved with water and alcohol because they will mix, but oil and water will not. Now, let's get the density. All right, let's write density over here. Here's our density. And here's another thing about physical properties, and there's our density. All right, let's write it down. Use green. Why not? So we talked about color and the length. Density and mass go hand in hand, even though they're not the same, but we'll talk about that. Same with volume over here. So let's look at density. So when you hear density, let's do a drawing so I can show you. We'll do the drawing over here. Let's do a scale. It's a good thing there's a scale here. So if we had a scale, right here's a scale or a seesaw, whatever you want to put. And I had a block here. Let's say that was gold. And then we had a block here, and we'll say that was, say it was tin. Doesn't matter. And if they're the same weight, if they're the same, not weight, but if they're the same size, and they have the same volume, same size, same volume, gold is heavier because it's more dense. It's denser than tin. So with density is a physical property. You can see it on the scale. I'll make another scale. Basic definition is more mass is packed into gold than tin. So it's the mass per unit volume. Mass per unit volume. And mass, again, is how much matter you have. So there's more matter packed into gold than there is tin, even though they're the same shape. Let's get a better scale. All right, and let's change the color. Let's change it to black. So here's our scale, and we said before we had our gold, we had our cube of gold, and then we had a cube of tin, same size, same shape. Put our tin over there. And gold is denser. But gold is not the densest, even though some people still think it. Because we can put gold over here. Here's gold. And then over here, we can put platinum. Platinum is denser than gold. And we can even, and platinum is not the densest, by the way. Because osmium, right? So we can have this cube over here. Even though it doesn't look like a cube, we'll make it better. So we have osmium. And then over here, we have our platinum. So again, they're the same shape and same size, and yet one is tipping the scale and it's denser. By the way, osmium is the densest element. However, at high pressure, iridium can be the densest of the elements, iridium. So think of the keywords in physical. If you can see it, you can feel it. You can feel it. Some are smooth, some are rough. If you took copper, for example, copper is black, and it could, you can have some of that copper. Well, not copper. I'm saying carbon. Carbon is black, and some of that carbon could rub up on your fingers, and sulfur is yellow, and that sulfur can get on your fingers too. So it's the feeling and measuring and seeing and touching. Now, if we had, let's clear this out. And let's use blue. If we had an ice cube, here's our ice cube. A nice glass of lemonade. We want some ice. And if the ice is melting, here it is, it's melting everywhere. So the ice is melting is a physical change. It's still ice. It's still water, right? An ice cube is water. It's H2O. It's dihydrogen monoxide. It's H2O. And if it melts, it's still H2O. It's just in a different state of matter. So melting ice is a physical change. So again, just to review, not preview, but to review, if you see it, if it changes, and the change, like going from solid to liquid, and it still stays the same, it's the same substance, it's a physical change. But if it does change itself, it becomes something else, that's a chemical change. So let's look at that. So here's the chemical changes. Rotting fruit, right? Let's get our pen, right? Who wants some rotting fruit, right? Flies like rotting fruit. Somebody likes it, right? So when fruit rots, the pear that was ripe before now is rotting. It's not necessarily a pear anymore when it rots, right? And you have the bacteria and toxins inside there. Wood is a great example. When you burn wood, it turns to ash. So ash is not wood. That's a chemical change. You take iron and it rusts. It's a chemical change. When you're cooking an egg, photosynthesis, those are chemical changes. When you take your food and it goes into your stomach and it digests, and all this acid is breaking down the food, it's turning it into something new. Your body wants glycogen. It wants glucose. Glucose, which eventually could make glycogen also. So your body's turning your food into glucose. That's a chemical change. And here's a few more. We talked about photosynthesis, digestion, rust, combustion, fermentation, right? For wine and beer. You're turning it into something new. You're taking the grapes and the yeast, you're fermenting it, you're aging it, and it turns into wine. So that grape juice turned into wine with a little help with yeast. So that is chemical changes. And here's an interesting one, washing your hands, which we all should be washing our hands, right? When washing your hands, when the soap and the water mix, it's a chemical reaction going on. So over here, it's reactions, not necessarily chemical change, but the chemical reaction and the dirt on your hands or bacteria on your hands, the dirt will be connected to the soap. So then the soap has this end to it. Let's just do our little very simplified version of it. It has a kind of a end to it, like a poked end. And they call that end, that's the hydrophobic end. I'll write it down for you. Hydrophobic. And it's called hydrophobic for a reason. Hydro is water. Phobic means you're afraid of it. So in a sense, this end of the soap doesn't want to react with water. Instead, it kind of attaches itself to dirt and bacteria. So when you're washing your hands, the soap attaches itself to the bacteria. Let's say here's a little bacteria over here. And so it just washes down the drain. So this is a chemical reaction, not necessarily a chemical change. And here's our review to hit it home. Let's get our pen going. Switch it to yellow. Why not? Let's clear that out. So, the log. Here's the log just hanging out. Everyone's just hanging out by the fire. They use the log. They burn the log, having your s'mores. And at the end of the night, it turns to ash. That's a chemical change. Wood and ash are not the same substance. But if you have a lemon, you have a whole lemon, you cut the lemon, it's still lemon. Now, the better example would have been the ice cube, right? If you have the ice cube and it melts, now you have water. You had water before. It's just frozen water, liquid water. It's like physical change. So remember, physical changes, they don't change the element. They don't change the substance. Chemical, they change. All right, that's our video.